Hello and welcome to a quick little clip about rationalizing the denominator. Now, one of the problems that we are ending class with today talked about if you wanted to find your trig functions in example 2, and one of the sides of the triangle ended up not being a nice square root. In this case, we solved and we got square root of 72 as one of the legs of our triangle, and that only simplified to 6 root 2. Now remember, we did that by breaking up 72 into a perfect square of 36 times 2. 36, when we pulled it out, became a 6, and the 2 was stuck inside the radical. So 6 square root 2 was what we got as this side of our triangle. Now, when we go and find our trig functions, sine, cosine, tangent, and so on, we're going to use the same general ratios that we talked about in our earlier examples. Sine, we're going to do opposite over hypotenuse. So opposite would be 3 over hypotenuse of 9, which would be 1/3. And our cosecant would be, in this case, 3 over 1, or you could say 3. Our cosine is adjacent over hypotenuse. In this case, our adjacent side is this kind of ugly 6 square root 2 over hypotenuse of 9. I can, in this case, simplify the 6 and the 9 since they are both outside of the radical. I cannot simplify the 2 because it's stuck inside. But the 6 and the 9 can simplify to a 2/3. And so in that case, I get 2 root 2 over 3. Now, when I flip that, I get 3 over 2 root 2, and I'm going to explain how we're going to adjust that in just a moment. I'm going to continue and find my opposite over my adjacent for my tangent. My opposite is 3 over my adjacent is that 6 square root 2. Again, I can simplify the 3 and the 6 because they are both outside of the radical. So I'm going to get 1 over 2 root 2. And my cotangent would be that flipped, which would be 2 root 2 over 1, or you could just say 2 root 2. Now you'll notice 2 of these answers, the secant and the tangent, I didn't box my answers yet. And the reason I didn't box those answers is that I don't love that in my answer so far, I have the square root 2 stuck in the denominator. We don't want to have radicals in our denominator, and there's actually quite an easy way to get rid of that. So I'm going to go ahead and scroll down and remind you guys about something called rationalizing the denominator. Then I'm going to be able to apply it to the problem that we're doing right now, and hopefully you can see how it all comes together. Now, I came up with a very simple example here where I just have 1 over 3 root 2. And again, it's the root 2 part that we don't like in our denominator. Now, we can multiply a fraction by anything as long as we do the same thing on top and bottom. If I multiplied top and bottom by 10, I can do that because 10 over 10 is really just like multiplying by a 1. In this case, however, what I'm going to do is I'm going to purposely multiply top and bottom by whatever that radical is, in this case square root 2, that I don't like in the denominator. What that's going to do is it's going to move that square root 2 to the top, and what I can do now is I'm going to be able to clean up this denominator. Now, notice what I have here is I have 3 times square root 2 times square root 2, which is really like square root 2 squared. Anytime you multiply something by itself, it's a square. Well, square and square root cancel each other out. So we really are left with the square root of 2 on top over 3 times 2. In this case, square root of 2 over 6. Now, as we practice problems like this, you're going to be able to probably start doing them a little bit more kind of smoothly as opposed to having to show all that work. Let's say I have something like this. If I want to rationalize this, I can multiply top and bottom by the radical that I do not like in the bottom. That's going to move the root 3 up to the top, and then I'm going to basically have 4 times 3, what's under the square root, get rid of the square root, and I'm left with just a 3. So I have root 3 over 12. Let's do one more just to show you. I don't know, I'll put like a 2 on top, and then let's go 5 root, let's say 6. Okay, so I'm going to multiply top and bottom by the radical that I want to get rid of on the bottom, which is square root 6. So I'm going to have 2 times square root 6 on top now. And then I'm going to have 5 times 6 on bottom. 5 times 6 is 30. I could then simplify the 2 and the 30 as 1 and 15. And that would give me root 6 over 15. All right, so let's adjust these problems up here. I had 3 over 2 root 2 for my secant. I'm going to multiply top and bottom by that radical that I want to get rid of, in this case, a square root 2. That's going to give me 3 root 2 on top, and I'm going to have 2 times 2 on bottom, which is just a 4. Same idea for our tangent. I'm going to multiply top and bottom by the square root that I want to get rid of. So I'm going to have a square root 2 on top, and then I have 2 times 2 on bottom, so that is square root 2 over 4. All right. I hope that helps give you a little refresher on rationalizing the denominator. Please let me know if you have any questions, and otherwise I look forward to seeing you guys tomorrow. Have a great day.